Elisa Bertino. Elisa is one of the people listed in the LTE Cellular Networks Hall of Fame. Everyone recognizes her for her work in security and access control of distributed systems and networks. And with this much one-line review, I would turn the floor over to Elisa for her to share her opinion and views on what the networks will look like some 25 to 50 years from now.
Okay, Dinesh, thank you. Let me share. And I hope you can see my slide.
Yes, we can see the slides.
Okay. So thank you very much for having me as a part of this panel. So in my presentation, I'm going to provide my view on cellular wireless communications and with emphasis on security. Now, of course, a wireless network has seen an explosive growth and continuous evolution over the past decade. We are all familiar with 4G LTE, which has increased the bandwidth available from mobile devices. 5G radio has enhanced the transmission speeds and cell capacity. However, technologies in many fronts continues to advance, and next generations is already being discussed and worked out. Now, it's very difficult to predict what the future can be, but let me say that there are a lot of fascinating applications. The new generation wireless systems will have to support a novel form of societal communications, application and trends. Among those trends, some very fascinating applications include holographic communications, haptic internet applications, and connectivity of everything. And among those, connectivity of bio and nano things is particularly fascinating to me. People are also mentioning the chip-to-chip communications. Instead of using wires, one can use wireless communications and nano networks, and of course, Industry 4.0. What is very important to say that for all those applications, latency will be a critical requirement. And so we need not only to have a bandwidth, but really be very quick in transmitting data. And we can also see that next generation wireless systems will be about connecting devices, robots, autonomous systems, rather than just humans with their mobile phones. And you see in the recent data of the growth of year over year for the cellular IoT connections in 2020 and 2021. Those are data as of September this year. There's been a little bit slowdown due to the pandemics, lack of supply of chips. But what is very important when you look especially on this IoT and in domains like Internet of Bio and Nano Things, which applications will be really possible and enabled by wireless networks also depend on energy charging technologies. Because if those devices needed to communicate quickly in order to support the real-time application, they also need a lot of energy. Fortunately, there are a lot of interesting progresses on this front. Now, of course, still I cannot predict what the networks will be, but certainly they will be more complex than ever. And complexity appears in many different layers and components. For example, wireless systems will be part of even more complex network systems. A very well-known example is the integrated space networks. As you can see, there will be now networks supported by satellite that will communicate with the devices on the ground, moving vehicles, and so forth. Now, the problem with this complexity is that in general, complexity is the enemy of security. And especially when you combine systems which have a different security posture, this is going to be a problem because attackers can get into the less protected system and through wireless movements can attack the other system. But complexity is also at the very small level of the device themselves. We already have the phones that support 4G LTE, 5G, Wi-Fi, and Bluetooth. However, now there are plans to add the satellite communication, Wi-Fi, which works at 60 gigahertz, a light-based communication. What is very interesting here is that each communication technology has its own use cases, which means we will have a lot of different wireless technology on the phones to better support a specific class of applications. Now, the picture is made more complex by the fact that there are many different actors and operators. In addition to the very well-known mobile network operator, there are the virtual ones. There will be aggregators, mobile virtual network enabler, and so on. And even there are some very interesting proposals, one of which is by Professor Scott Schenker, who is one of our panelists today, where he proposes the notion of broker. Now, an important requirement when dealing with these complex systems is a seamless experience for end user and device. So the idea would be that a user may move across the different networks and they shouldn't really see any difference. If the user is talking, he can continue talking without any interruption or disruption. However, as I mentioned before, complexity is the enemy of security. This is very well known. Now, I want to give you a couple of examples. And we just go at the hardware level. This is a very interesting example, and it focuses on security due to mechanisms to support the coexistence of different wireless communications. In particular, as you can see from the slide, there is a combo chip.
Elisa, sorry to interrupt. I think you're not sharing your screen. Could you double check, please?
Why? Oh, I see. I don't know why. Okay, sorry. Let me
unshare and share it again. Change
okay,
for all.
can you see now?
Now we see you. Thank you. Your screen.
Okay,
So
sorry. Okay, that we need to hear the slide exactly. In case you want to see the previous one, that was the architecture. Let's talk. Sorry for this. So this is a very interesting work, which basically, as we can see in the slides, there is a combo chip. This combo chip is used to basically support two different wireless communication technology, Bluetooth and Wi-Fi. The coexistence on the same chip is critical for performance. But as those researchers found out, through a lot of experimental analysis, is that this coexistence introduces some vulnerabilities. And actually, there is a long list of vulnerability, but one example is the one where the attacker, through Bluetooth, can reconfigure the serial enhanced coexistence interface via Bluetooth by writing certain values to a specific register. This results in a voltage drop from which then halts the process of communication with the Wi-Fi and also causes kernel panic on other devices. Now, this is very interesting. So you can expect that when we will add more wireless communication to those devices, similar issues may happen. The other example which I want to show is an example which involves voice over LTE and voice over Wi-Fi. The idea here is that when you are talking on the phone, you could seamless your phone move between those two technologies. We have done some initial experiments and we have noticed that on certain phone models, when voice over Wi-Fi is being used, attacks to voice over Wi-Fi prevent the phone from receiving calls on voice over LTE. Which means, yes, we have a certain redundancy here, which could make the communication more resilient, but sometimes how the protocol works, this is, it's not really exploited to the best. And the reason why when a voice over Wi-Fi is used, The phone does not execute the paging protocol on the cellular network. This is a protocol which the phone periodically does to check if there are incoming calls or messages on 4G LTE. And so there are all those issues. To this, we need to add vulnerabilities. No, the problem here is not really the problem of humans talking on the phone, but the problem will be when those communication chips and systems will be used by autonomous devices with the real-time requirements. Here, even a time in which there is no communication for 2 minutes may have some consequences. And that's really the problem. Of course, we can expect more vulnerabilities due to vulnerabilities of cloud infrastructures used to support the current and next generations network. In this respect, there is a very interesting report by IBM X-Force, which talks about various vulnerabilities still existing in cloud systems. And of course, we need also, unfortunately, to add the problem of security. To enable all those flexibilities, interoperation among different communication technologies, software is really the key. But software, unfortunately, is still very insecure. So software is always plagued by many different vulnerabilities. And this is going to be a problem. And this also brings with it the problem of software supply chain. This was the case of the very well-known SolarWind breach, which was in part due to the problem of software supply chain. And those will affect the communication networks since we are moving toward the softwareization of those systems. So, having said this, I hope I didn't scare too much the audience with all those problems. So, what can we do to address security? Well, at least we should, do 2 things, in my view. Come up with network security foundation and also have a systematic network security life cycle. Security life cycle is very important because if you look at many of the breaches that we see today, sometimes they are due not to the presence of vulnerabilities like the ones I showed you before, but they are due to the lack of security management, the lack of proper configuration of security tools and appliances. And that's what one should do to have at least a reasonable level of security. But let's start with the security foundations. Of course, identifying what are the foundation of network security challenges, and not certainly try to do so, because this it's it's a huge kind of undertaking. But from my point of view, one should at least make sure the network protocols and their implementations do not have vulnerabilities. Keep in mind that those protocols are multi-step, stateful, and involve multiple parties. And of course also the hardware. We need to look hardware for side channel vulnerabilities and so forth. Now, we developed an initial systematic methodology that we used to analyze the non-access stratum of 4G LTE. As you can see, as several steps, and actually was quite successful. We were able to find 10 new vulnerabilities due actually to the standards of the 4G LTE standard. So we discovered that those issues in the standardization document. However, applying such a methodology entails a lot of challenges. The first important challenge is that one has to come up with protocol abstraction, and we had to do this from standardization documents, which are written in natural language. We did this manually, but this is a very huge task. So automatic approaches, perhaps based on AI techniques for natural language, would be important. The other is complementary, is how to extract such abstractions from possible implementation. This is important to verify compliance of the implementation with respect, for example, to the protocol specification. Now the problem is how to extract this model is challenging. We used an approach based on a symbolic execution, but the model is too big and therefore is not amenable to formal verification. And for this, one has to come up with proper heuristics. Now, let me turn to the security life cycle. As I mentioned before, attacks are due often to misconfiguration. So in general, a generic security life cycle should consist of several phases. The first is prepare and prevent, learning, deploying the network security policies, which can be very huge in numbers, especially if one starts adopting zero trust architectures, assuring the correctness of network programs, but then even the best prepared system may still be attacked. So you need to monitor your system to detect anomalies, identify connected devices, and so forth. Once you have detected anomalies, you need to diagnose the anomaly. For example, identifying attack points, affected the network portion, and possibly even predict the next step of the attack. And then finally, you have to react to the attack. Typically, you may contain the attack, taking steps to isolate a portion of the network, deciding which applications can continue working and which one can be delayed, then taking steps to bring back the network to normal state and so forth. Here we have a lot of interesting opportunities, for example, for machine learning. One example is an approach which combines two machine learning models for protecting against denial of service attacks. So one model predicts the signaling workload, and the other model determines if the predicted workload is anomalous. So this is very interesting. This is the first time I see this type of approach. We have additional interesting techniques using, for example, reinforcement learning, which allows the agent, an AI agent, to slow down potentially malicious flows, so to give a more opportunity to observe the flow and determine if it is really malicious. And of course, so those are just some opportunities. I want to conclude. So the next generation wireless network will focus a lot on latency, will be age-based, heterogeneous, and more open. They also will be more shared. We can expect that high margin values of connectivity will be mainly on the applications running on top of the network infrastructure. The infrastructure itself and the underlying spectrum can be dynamically sliced and shared to reduce the cost of deployment and management. However, next generation wireless network will have to be secure. And with this, I have ended my presentation.
Thank you, Elisa. I think it's time for a brief question and answer session, maybe just 5 minutes. So to all the attendees, if you want to ask a question to Elisa, please post it in the chat session, and we will request her to monitor and answer that. When did you see any questions in the chat session?
I don't see anything yet.
Okay.
I don't see anything.
That's fine. So Elisa, I do have a question for you. You emphasize a lot on the security needs or the security issues. So do you think there is even a half practical solution that can address all the challenges that we see in the security of the network currently and in the future? Is there any approaches, anything that may hold some promise of being a more secure network connectivity?
Yeah, this is an excellent point. In a way, you have to use a lot of security techniques, okay? So usually you need to make sure, again, for example, the protocols don't have vulnerabilities, hardware don't have this problem. The software managing, for example, interoperation has to be without vulnerabilities as well. Okay. We have a lot of techniques there. It's just that they have to be all applied. For security, there is not a single solution. Okay. But I want to mention another issue, which is very important. So sometimes people ask me, yeah, there are all those vulnerabilities like the ones we have seen for the, this chipset, the coexistence of different technologies. But will the attackers use such attacks? Will they really exploit that? For security, it will be very important to understand the motivation of attacks. Why somebody may want to attack a network infrastructure. That will be critical. Now, attacks today are motivated by financial gains. That's why we see a lot of ransomware every day. They are also motivated by espionage and sabotage. Okay. And those will be more critical because somebody can really try to cripple a country by sabotaging the networks. We have a lot of redundancy. We have shown that you may have integrated the space and terrestrial networks, but this integration has to be properly engineered to give them more resilience. But with security, our attitude is not if the attacker will exploit a vulnerability. It's only when we are very pessimistic from this point of view. And but unfortunately, in 50 years, we needed to be prepared because sooner or later some attacker may happen.
Thank you, Elisa. Thanks.
Thank you, Elisa. There is another question from Devendra. Hang on a second. He says, do you expect inline feedback from receiver to transmitter when the receiver detects any anomaly?
Okay, basically, this is an interesting and important anomalies. Have to be looked at the various aggregation level. In general, when there is an anomaly, the idea is to try to understand which is the reason for this anomaly. Okay, and the anomaly in the life cycle is meant more as an indication of a possible attack than one has to determine whether this is a real attack or has other reasons in order to take a proper reaction. So definitely anomalies are critical again to, be in time to react to an attack. The problem is not to have an attack. The problem is when you are not able to respond to the attack within few minutes.
Thank you, Elisa. Wendy, any other questions on the chat sessions?
Something like, hang on a second, I just lost my screen. Can you comment if 5Gs will bring more challenges to security with EMBB, MTC, URL, LC?
Actually, 5G, I don't think so in a way. It inherited some of the issues of 4G, for example, some privacy vulnerability on the paging protocol, but it's been designed to be more secure.